We're now solving the next question, 17 of this exercise for the work power energy for this M1 topic. Question statement is a car of mass 600 kg travels along a straight horizontal road starting from the point A. The resistance to the motion of the car is 750 Newton. The car travels from A to B at a constant speed in 100 seconds. The power supplied by the car engine is constant and equals to 30 kilowatts. Find the distance AB. The next part, the car engine is switched off at B and the car speed decreases until the car reaches C with a speed of 20 meters per second. Find the distance BC. The third part, the car engine is switched at the C and the power is supplied is constant and is equal to 30 kilowatts. The car takes 14 seconds to travel from C to D and reaches D with a speed of 30 meters per second. Find the distance CD. So, mass of the car is 600 kg and the resistance to that motion is 750 Newton. The time taken from A to B is 100 seconds and it is moving with a constant speed. That means acceleration is equal to 0 and the power of that car is 30 kilowatts. So you have to find out the distance AB. Since it is moving on the straight horizontal road, so we can write it as A, B, C, and D. Here, speed is constant, so acceleration is equal to 0. We know one thing, that the power is basically equal to 30,000 watts. So power is basically equal to driving force into velocity R, work done by driving force over time. Since time is mentioned in this statement, so we are going to use the time formula there. That is, power is basically equal to work done by driving force over time. So work done by driving force is equal to power into time. Power is 30,000 into time is 100 seconds. So this will be the work done by the driving force into joules. Now, they are asking about the distance traveled from A to B, where resistive force is 750 Newton. We know one thing, that driving force minus resistive force is equal to net force. But since acceleration is constant, velocity is constant, so acceleration is equal to 0. So in these words, driving force is equal to the resistive force, and that is equal to 750 Newton. Now you can find out the speed of that particle, that is, power is equal to driving force into speed. Power is 30,000. The driving force is 750 into the speed is v, and that thing is equal to 30,000 over 75, 750. So which is being calculated? Which is equivalent to 40 meter per second. At the point B, speed is 40 meters per second because it is constant in this motion from A to B. Now we are going to find out the distance from A to B. We know that work done by driving force is equal to driving force into distance. So work done by the driving force is basically equal to 30,000 into 100. Driving force is 750 into the distance AB, which is denoted by S. So S will be equal to 30,000 into 100 over 750, and then S value is equal to so this distance is equal to 400 meter for AB distance there. So this is the calculation of this first part of that numerics. So we're going to start now the second part. The car engine is switched off at B. It means there will be no driving force, and the car speed decreases from until the car reaches C with a speed of 20 meters per second. Find the distance BC. So for the distance BC, when it's going to reach at the point C, it is going to move with the speed of 30 meters per second at C. And it is because engine is switched off, so driving force will be zero. So for this part, driving force minus resistive force is equal to MA. Since driving force is zero and the resistive force is still same 750 is equal to mass of that car is 600 into acceleration. So acceleration will be equal to minus 750 over 600. So this is the value of that acceleration there. And now they are asking find the distance P to C. So the distance from B to C, we are going to calculate. We can use this equation V square minus U square is equal to 2AS. V there is 20 square minus U there is 40 square is equal to 2 into acceleration is minus 1.25 into S. So S will be equal to S will be equal to 400 minus 1600 divided by 2 into minus 1.25, and that S will be equal to 480 meters. So this is the distance of B to C for that motion of this car starting from A going towards D there. The last part. The car engine is switched on C and the power it supplies is constant, and that equals to 30 kilowatt. The car takes 14 seconds to travel from C to D, and when it reaches at the point D, its speed is 30 meters per second. Let's say the distance from C to D is denoted by x. So we can use this equation: work done by driving force minus work done by resistive force is equal to change in kinetic energy of the system there. Work done by driving force is given there, 30,000 into 14 minus work done by resistive force. Resistive force is 750 and the distance is, we are going to mention it by x, is equal to half. Mass of that car is 600 into v square at c, that is 30 square, minus v at c is 20 square. Then 750 into x is equal to 30,000 into 14 minus 300 into 30 square minus 20 square, and finally x, which is the distance of C to D, is basically equal to x is basically equal to 360 meter, which is the distance traveled from C to D. So this is a complete solution of this problem number 17. And if you have any question, you can give me the message or you can email to that part.